Hello, class. Welcome to CS 1410. My name is Pierce Scott, and I will be your instructor this semester. Um, a little bit about myself. Um, I got my bachelor's degree in computational statistics and data science from Weber State. Um, some of you are probably in the same degree. It's a fantastic degree. I later got my master's degree in data analytics. And right now I'm working as an analytics engineer for RC Willie. Um, yeah, and I love sports. I love video games. Love my family. Pickleball, disc golf, basketball. Do it all. Um, I have a beautiful wife and two beautiful children. Liam is 5 years old. And this right here is Davy. She is 2. They are a lot of fun, and you'll probably hear me talk about them a lot this semester. They're a handful, but I love them. Um, if you were in person, I would make you tell me about yourself and humiliate you all. So consider yourself lucky that you're online. And I want to go over some of the class rules and expectations, specifically over ChatGPT and getting help from friends. So I'll go over that in a minute. Let's first open up the syllabus and take a look. Let's see if you guys can see this a little bit better. Like I said, my name is Pierce Scott. It is Pierce Scott, not Scott Pierce. That's my life curse that my parents cursed me with, was a backwards name. My email, this is the probably the best way to reach me. I'm usually pretty quick to respond. Office hours are sporadic because I teach adjunct. I do have a day job. However, the best way to reach me, or if you need to sit down with me, is using the Google Calendar link. That can be found in the course under the resources module. If a time doesn't work, you need to see me, and there's not a time slot available, just email me. We can figure something out. Even if it's a phone call or something, I'll help you. The textbook is optional. The hard thing with C++ is that it's constantly updating. It's a very active language. A lot of developers use it. And so textbooks don't stay relevant for very long. We did have a professor make a pretty good textbook. Some things are outdated. I'll reference it a little bit, but not to a point where I expect you guys to really be digging into it and relying on it heavily. But that resource is there. Yeah, so this class is it's kind of two things. C++ as the language, meaning learning the syntax, the quirks, understanding what a compiled language is versus an interpreted language. And the other part is object-oriented programming, which, C++ is a tool. Object-oriented programming is a programming paradigm. It's a way to think about coding. There's lots of different languages you can use with object-oriented programming. So we're learning both parts. C++ in the beginning, and then about 6 weeks into the course, we're going to switch over and really hone in on the object-oriented side. This is a 4-credit course, so expect 4 hours with teacher instruction. If you're in my online section, probably less, honestly, because you'll just be having my recorded lectures versus the in-class time. And then expect another 2 to 4 hours a week practicing the concepts. I have a couple of assignments, kind of a studying assignment, and then a lighter programming assignment just to get your feet wet, and then the big homework assignment every week. And then there's also quizzes, but they're not traditional quizzes. They're more of like a study guide. You have a time limit, but it's unlimited attempts, so it shouldn't be too bad. So with all that and you're studying, I mean, yeah, you're probably looking to another 2 to 4 hours at least, depending on how much experience you have. So tips for success. This is an intro course, so programming may be a newer concept for you. Many of you probably only have about one programming class under your belt, maybe two. Um, it is a different way of thinking. I mean, you've gone to school your whole lives. We're taught to think a certain way, taught to study a certain way. And then, at least for me, when I learned to program, I was kind of blindsided a little bit. It was not what I expected. What I mean by that is I was used to studying a textbook, memorizing the answer, applying that, and getting through school. Think of like a history class. You learn the dates, you learn the world events, then you regurgitate them onto a test. Programming isn't that way. You will never have all the answers. Sure, you'll learn tools, you'll learn efficient ways to do things, and you may see similar problems, but every time you encounter a challenge, it's going to be new. It's going to be a puzzle that you have to solve. I mean, I deal with that at my day job every day. So you have to be okay with not knowing the answer, and you have to be okay solving puzzles. You have to actually love solving puzzles. That's what this is. Um, I don't want to scare any of you away. Anyone can be competent programmer. I want you guys to give it a good try, but just know that you might have to approach it a little differently. And for some of you, it may not come as natural. Definitely did not come as natural to me. Um, yeah, you're just gonna have to keep grinding, and it's really practice does make perfect. So hang in there. Um, it really is a blast once you start getting the hang of things. So determination, determination, determination. I mean, really practice. And then the last thing I want to stress is ask for help. I am here as a resource. Please, please, please do not don't hesitate to reach out to me. I want to help you. And then reach out to friends and family, other siblings who are programmers, or friends or mentors or teachers. Ask for help. Practice really does make perfect. Um, Code leverage from outside sources. This is really the ChatGPT section. So with ChatGPT, it's complicated with me. I like it. I like it a lot less than I used to. I think it's getting a little bit stupider. Um, Mixture between how the model's being trained versus, I think, how open AI is dictating its business. I think ChatGPT isn't as flashy as it was when it first came out. Um, so don't rely on it. Even in my day job, I'll ask it questions, and I'm noticing more and more it's just stupid. It's just not what I'm looking for. And if you just blindly copy and paste, not only is that cheating, and it will be enforced, um, you're just probably not going to get the right answer. It's really good for understanding syntax. Like I've noticed that asking ChatGPT the syntax of some code is quicker and easier than going to Stack Overflow. So things like that, I mean, go for it. I am also okay with you leveraging some code as long as you understand what you're doing and can explain it back to me. But the blind copy and pasting code is not acceptable, um, and it will be considered cheating. Basically, the way I look at it with ChatGPT and also with leveraging code from like friends, anything that you copy and paste, anything needs to be dictated. You need to put a comment and say, "Hey, I didn't understand this thing. I went to Stack Overflow. I learned this thing. I get it now. This is the code I leveraged." Um, Programmers do borrow code, but we also need to make sure we understand what we're doing. And you're in a class, right? You're here to learn. So dictate everything. I'm gonna be strict on that. Also, with some of the tools we're using this semester, I can actually see all the changes that you're making in real time. So if I look and all of a sudden I see 500 lines of code appear out of thin air, I know that you copied and pasted it. So if I see that and then you don't dictate it, we're going to have a chat about that. Um, but yeah, I want to simulate this class as close to a real working job as possible. And so, if to be fair to you guys, I'm going to treat you how I would treat my coworkers and those who work for me in my day job, which is I expect you to Google, I expect you to ask friends. At the end of the day, we want the project done, right? But if you don't know what you're doing, you're actually shooting yourself in the foot and your employer in the foot. So just make sure you know what you're doing. You're asking questions. If you borrow code, annotate it. Now, if you borrow all of it, even if you honestly tell me that you are, that's not going to work either, right? Think of it as like you're writing an essay with an in-text citation and the whole thing is in quotes, right? That's not going to fly. So just use your brain on that front. Late work. So I'll explain a little bit about the class rundown a little bit later. But basically, we have read and report assignments. This is 45 minutes of studying the topic. You're going to do it on your own time. I don't care where. You can watch a YouTube video. You could even ask ChatGPT. You can write a little program, your own little project. Really anything. The textbook. But I require 45 minutes of studying. And in addition to that, we have the try it out assignments, which are lighter coding assignments. They're not as intense as the homework. And in fact, I don't really expect you to get the right answer all the time. It's more of you've studied a little bit and now you kind of want to put it into code and see what happens. Those two assignments are built around you studying. So I'm not going to accept late work for that. That wouldn't make sense. So I don't accept late work on those two things. The homework, I'm gonna try out this. Admittedly, this is the first semester I'm trying this, but I'm gonna try a 3-strike policy. So the first late assignment you turn in, and when I say late assignment, I mean the homework. So the first late homework assignment, you can get up to full credit. The second one, I'll give you 75% credit. The third one, up to 50% credit. After that, I don't accept late work from you. I know I'm kind of stingy with that, and I've honestly debated it. If you want, if you want to debate me, we can do that. But the reason why I'm taking the stance is, well, two reasons. One is a selfish reason, and the selfish reason is I don't want to grade. I don't want to grade a whole bunch of stuff like 2 months later. I don't have time for that, honestly. So that's the selfish reason. But the other is just to prepare you for your job. Like you can't miss deadlines, right? But you've all been in school long enough. You don't need that lecture. But that's why. Letter grades, pretty standard. Yeah, let me know if you have any questions on that. And then the week breakdown. We're actually going to do a Python review for week 1. Then next week, we'll get into the C++. Week 6 is when we actually get into object-oriented programming. Both the midterm and the final are going to be projects. I have a lot of freedom, or I give you guys a lot of freedom on what to do with those. And yeah, and then this is the course and department policies, fine print. I'll let you guys read that. But that's the syllabus in a nutshell. Please let me know if you have any questions with it. The ChatGPT stuff and the friends and family helping we went over. Okay, class navigation. This is where things are gonna get a little tricky, but we're gonna get through it. So I already kind of explained this, but if you go to your Canvas and then you hit the home page, you are going to have your modules. These are your resources. How to think like a programmer, I'll talk about it in a minute. It's a fantastic, it video that honestly changed how I thought about programming. The textbook, my Google Calendar link, then the our all our content, class content. If you look here, we have our lecture. This is a link to the PowerPoint. I'm going to post the videos that I'm recording here. This is our read and report. These are going to be due on Wednesdays. And like I said, I just require 45 minutes of studying, preferably the topic that we're learning about. But if you have already got a good grasp on it, you want to move on, you honestly can study anything related to C++, object-oriented programming. I just want you to study for 45 minutes. Take notes. If it's a program, if it's pen and paper, if it's Word document, I don't care. Just take some notes and then turn it in by Wednesday. I know it's a little hand-holdy, but I really want to make sure that we're understanding the topics, not just hitting keys on a keyboard. So yeah. Then I have the try it out assignment. This can be a little frustrating because I expect you to do the read and report, and then before really even watching the lectures or attending class, I'm going to have you try it out. Try out what we're learning. This one for this first week is honestly just setting up, because there's a lot of tools to set up. And then later in the semester, they may be some light programming assignments. I don't expect you to get it all right. If you do, great. If you don't, that's fine. I just expect you to try. Sometimes we understand something conceptually and then we try to apply it and we're like, okay, wait, I don't get this. So I want to kind of prime you guys for the lectures by requiring those two assignments. Then after that, we'll have our lectures and then the homework assignment itself. And then the quiz down here, like I said, is a review quiz. There is a time limit. I do encourage you to do closed book. I don't have a way to enforce that, but it would, I feel like you learn better if it's closed book. Yeah, but you have unlimited attempts. So if we take a look at this one, what does the print function do in Python? Anyway, just a Canvas quiz. And you can take that as often as you want to or need to. And notice that the homework and the quiz are going to be due on Sunday nights at 11:59 p.m. So you have a whole week to think about these things. I do encourage you to look at the homework earlier in the week so you can start thinking about it. So with my day job, I spend probably 15% of my time actually like clicking away on a keyboard, and all the rest of the time is thinking about what I'm trying to code. I'm drawing on a whiteboard. I'm discussing it with my team, talking about things, thinking about things. That's kind of what a programmer does. And so I encourage you to look at the homework early. Try to understand what the problem is that you're going to be solving. Think about it. Think about how you would implement it. Give it a shot. You might hit a brick wall. So take a step away. Think about it some more. And then really the last couple of days should really be like you've got it done. You just need to debug it. I noticed in the past my students would kind of start the homework Sunday or Saturday night, and they're cramming because it takes, depending on the week, it takes a little bit of work to do some of these assignments. And then Sunday night comes and they haven't debugged it because they were so focused on just coding it in the first place, just cramming it in, that it is just riddled with bugs. So look at it early, give it a shot, come back to it. That's honestly the best way, in my opinion. The way that you actually turn in both the try it out and the homework assignment is through GitHub. I'm going to make another video talking about all the tools we're going to be using, such as GitHub, Visual Studio Code, CMake. But basically, GitHub is an online kind of platform where your code kind of sits in the cloud, and then you can pull it down locally onto your machine, and then you can push it back up, and then other people can clone, is the word, clone your repository, grab your code, modify it, push it up. It's really cool, and it is used in the industry pretty heavily. So for our assignments, so let's look at this one. This is our first homework assignment. It says use the following link to access the homework, and it's a link to GitHub. I've already accepted it, but the first time you open it, it'll be like, do you want to accept this assignment? Yes. And then this link right here is what we call a repository. So if I click on this, it takes me to GitHub, and it takes me to, this is where my code would be. Now I have starter code for you guys, so you're gonna be seeing kind of the same thing. So this link is actually what you're going to turn in. So you're going to pull it down and onto your machine. You're going to code. You're going to push it back up, and then you're going to take this link and you're going to copy it. And then when you go to turn in your assignment, you actually, what did I do? You actually post the link right here. And that's what you're turning in. Because then I'll come in and I'll click on the link. I'll go to your repository, and then I will be able to test and grade your code. So that is what the majority of the assignments that you turn in are going to be, this format. And like I said, I will make a video that goes into it deeper. If we go back to here. Yeah, okay. So I want to go through two more things before I end this video. Tips for success. I already went over it a little bit. I think the one other thing I would add is pseudocode as your friend. I think that is the big thing. What I mean by that is you should not be opening your laptop ready to go and code first thing. Like I said, I spend the majority of my time thinking about coding rather than actually coding. So understand the problem, get a pen and paper, and it's like drawing a maze. Think about what you're trying to solve, understand it, research it. A lot of times you may be encountering problems in a domain that you're not familiar with. For example, I spend a lot of time working with inventory data. So we're talking about product counts, their costs, things of that nature, when things are coming in on purchase order. But then every once in a while, someone will throw me a curveball, and an accountant will need to know something for their general ledger, or a salesperson will want to know how much commission they're making, or whatever. And these are areas that I'm not experts in, or I'm not an expert in. So I need to take the time to kind of do a little crash course to kind of understand. You guys are going to go through the same things. This first assignment, you're going to make a video game. You may hate video games. You may love video games. Either way, you're going to have to understand enough to know what to code. Another assignment is you may have to make some complex math library, and you may hate math. You may not have taken that level of math. That's okay. You don't need to know everything. I'm not going to quiz you on calculus. Just take the time to research what you need to know to be dangerous. So understand the problem, and then write it down on paper. So I kind of, I'll have to show you, but I kind of on paper write like how I'm navigating through it. Like, okay, so I need to do this thing, but then what if this happens? Well, then I need to look at that thing and maybe look back over here. And it looks like a jumbled mess that probably no one understands. But putting it on paper helps you materialize those abstract thoughts and actually make an actionable plan with it. So yeah, that's the big thing. And I do encourage you to watch this video. It really is fantastic. On that same note, my rubber duckies. If you were in person, I would give you all a rubber ducky. This is something called the rubber ducky method, which you may have heard of before. But basically, you get a rubber ducky or whatever little fidget or toy that you keep on your desk, and you have to audibly talk to it through your problem. People will think you're crazy, but you're a programmer, so you probably are, like me. But you need to talk to the rubber ducky and be like, okay, I'm trying to do this thing. I've tried this thing. It doesn't work. I'm going to try that thing. And you will surprise yourself that when you actually audibly speak rather than just think, the answers just flow to you a lot of times, or a lot of them do. So go buy yourselves a rubber ducky and talk to it. It really does help, I promise. Anyway, I'm going to cut the video right here. In the next video, I will be going over the setup of GitHub, of CMake, all that fun stuff. Walk you guys through that. And then I will actually make another video jumping into the meat and the potatoes of what we're learning this week. So thank you. I am really excited for the semester. Please let me know if you have any questions. I look forward to it.